Hello and welcome back to Cracking the Cryptic, and the puzzle today is called Killer Multiplications of 9. Now before we get to the puzzle, I'm somewhat experimental in my setup. My daughter has shown me how to record with OBS. I'm hoping that I can use my normal video editing software to cope with that, and this is all because of the sound problems. Yesterday worked all right, but it was a bit of a fluke and I cannot reliably get the sound to work, and I think it's all because of some sound enhancing software called Nahimich, which MSI keeps propagating on my computer without my say-so. So it's very annoying, but we've got a proper workaround now. In fact, being able to record in OBS may be a good thing in terms of my being able to stream stuff in the future. Let's see how this goes. Anyway, this is somewhat experimental. I really hope I don't ruin this interesting puzzle sent in by Sajjad Haidari, and I'll go through the rules in a minute. I do want to trail our brilliant Sudoku hunt on Patreon at the moment, getting a lot of correct answers, people working their way through that, sometimes with the help of Patreon chat, and frankly we don't consider that cheating unless you ask for the answer there. And well done to anybody who's got through it. We are getting quite a few correct entries in now. So Patreon chat is on the Discord server. Both Patreon and Discord and all our apps and merchandise and Sven's SUDOKU PAD can be found on the links under the video, where the first one is to this puzzle. Now, there's a new rule here that we haven't seen before. Normal Sudoku rules apply. That's not it. We've seen that any number of times. And normal killer rules apply. So digits can't repeat in a cage. There's no repeat digits in this cage, and it must add up to 18, which is the number given. In addition, in each row and column I, the digits of 9 times I will appear in order. So you have to multiply the row number. So this is row number 5. Multiply that by 9, you get 45. And that means that 4 must appear before 5. Well, actually, in this column, we know that. These are the 2 given digits in the puzzle from the 1-cell cages. But that is the example given, probably so there's no giveaway here. And we know that in this row, 4 must appear before 5. The same must be true for this column, which is column number 5. This is row number 6, so 5 must appear before 4. And I mean, this puzzle is going to be good for our 9 times table memorization, if nothing else. But do give it a try if you feel up to the little bit of arithmetic required. And I am going to start now. Let's get cracking. So let's put in that 4 and 5 that are basically givens from 1-cell cages. Then see if we can figure anything else out. So row and column 1 are useless. There's obviously a 9 in them somewhere. That doesn't really mean anything. I don't think the rule is very helpful to start with at all. I think we're going to have to do just killer stuff. Right, how are we going to... There's a 1, 2, 3 cage. That's a start. 6 in 3 cells. Always 1, 2, 3. This 13 cage is either 5, 8 or 6, 7. And in this 10 cage, we can... in these 2 cells, we can only have one of the digits 1, 2, 3, or else we'll have too many in the column. And we can't have a 4. So we've got to have at least a 5 and one of 1, 2, 3. And that takes us up to at least 6. This can't be more than 4. It's not all that helpful. And the digit that goes up that is at least 5, I suppose it could be as much as 7 if this was a 7, 2, 1 cage. Doesn't really prove anything. We've still got 2 spaces left for 9, and those would do for 8 as well if it's not in this cage. So column 1 didn't yield as much as I was hoping there. Oh, here's a thought about the rule. In this row, 1 times 9 is 9 times I is 81, because it's row 9. So 8 must come before 1, but 1 cannot come in a 2-cell 12 cage or a 3-cell 22 cage, and it's not in this box. So 1 is in one of those 2 cells. 8 comes somewhere before it. Okay, well that at least means that this cage we can rule out 8, 4. This one we can't fully rule out 9, 8, 5, although interestingly, we can, because the column also has 8 before 1. So if you were putting 8 anywhere in this cage, it would fail to come before 1 in either row 9 or column 9. That's rather pretty. So that's a 9, 6, 7 cage. This cell in the same box can't be 9 or 7. So that one can't be low. That's a 6, 7, 9 triple. Oh, and these must be 1, 2, and 3 because they've been used up in this box. That's brilliant. That's a really entertaining break-in, actually. Well done, Sajad. Like that. This is now a 1, 2 pair. 9 doesn't appear in these cells, so it appears here. I don't know how much further we're going to get with this. Well, we can put 4, 5, 8 as a triple in there. And that one can't be 4, so it's 5 or 8. And suddenly, this cage can't therefore be a 5, 8 cage, or that couldn't be filled. Oh, this is brilliant. And now what I observed earlier about 8 and 9, if they can't be there, they have to be in these two cells. So let's put in 8 and 9. That comes into play. Now, these include 5 definitely, and 1 of 1, 2, 3. So this cage is either 5, 1, 4 or 5, 2, 3. Okay, I don't know what it is, but wow, that is a really interesting start. I didn't think this rule set would have such an early or impressive application, but it really was. That was brilliant in the 81s. I'm a bit blown away by that. 9 there, and we get a 6, 7 pair. I really hope the sound isn't off on this video, because it would be very unfair not to feature this puzzle if it carries on like this. Right, 9, 6, 7, 3 now. What about this 15 cage then? I want it to have an 8 in and not a 1, but 8, 1, it could actually have both. Remember, 8 must come before 1 in this column. Maybe I need to think about some of these other columns. Right, this is row 8. 9 times 8 is 72, so that 7 comes before the 2. So that's not a 2. That's quite interesting. 63. Aha! 6 comes before the 3 in this row, so neither of those can have the 3 in. And suddenly this becomes 3. They can't have 3. This is either 5, 2, 3 or 5, 1, 4 there. 6 comes before 3. Well, 3 is not in this box. So 3 is in one of those two cells, and 6 is before it in one of those two. 63, 72, 81. This one is 54. That's all too easily done. We've done 45. 9 times 4 is 36. And I don't think this is very helpful anymore. 27. Oh, that stops this being a 7. That's nice. Sorry, I'm in the wrong mode. 6 there, 7 there. 1 before 8 in this one. Let's go down. 1 before 8. So that can't be a 1 because it couldn't get in before 8. That is good. Oh, this rule set is really interesting. Much more helpful than I thought. 1 before 8 here now. Can't really do much with that. 2 before 7. No. 3 before 6 here. 4 before 5. So this can't be a 4. Of course. 5 before 4 in this column. 6 before 3. Well, that's been resolved already. 7 before 2. So this can't be a 7, or it would be after 2. And 8 before 1. Wow. I mean, I think we're going to have to cycle back through those columns every so often. So that we get a 1, 2 pair there. This is a 4, 8 pair. This is now a 3, 6, 7 triple. But that can't be 6, and this can't be 3. Haven't really used these other killer cages much. I've probably been forgetting about them quite badly. 4, 5, and 8 here. That can't be 5. Now, 9, 7, and 5 have gone, which are all the high odd numbers, but this cage needs either 1 or 3 odd numbers. Well, it can only have 1 now, and that 1 is either a 1 or a 3. So it's either 8, 1, 6. Oh, this can't be an 8 because it would not come before the 1. So that's so it's either 816 or 3, and there's no way to fill that with 12 others. Can't have 9, 3, 5, 7 or 8, 4. So it is 816. This can't be a 6 because of the grid. 8 must come before 1, so that can't be 8. That's the 1. 601. So we get a 2, 3 pair. That's really helpful. So that column's been done. This, maybe I should mark off the columns where I know I'm going to be okay, and rows. 8 before 1, 7 before 2, 6 before 3. I'm not going to mark that off. I've done the 4 before 5. 36, 27, 18. Okay, I'm going to just colour those. Orange means that the start of the column or row has been done. So this one is 18, 27, 36, 45. This one's definitely all right. 5 before 4, 6 before 3. That one's definitely all right. And 7 before 2. Okay, lots still to resolve. Now, 681 here. This can't be 18 or 63. It's either 27 or 45. This has to add up to 26. If that was a 3, it would be 8, 6, 9. Is that a problem for anything? I can't see how it is. That would work. This can't be 3, 6, but I don't know. There must be some helpful cage somewhere. Sorry, I'm being a bit slow here. 9's in one of those cells. That can't be 1, 9. Ah, 6 has to be... No, that's not that interesting. 6 has to be in one of these cells. I don't know. These cage totals aren't quite as high as I was hoping would be helpful, as it were. Right, come on, think again. Find something useful. So 8 before 1, 7 before 2 in this column. Right, that's quite interesting. If this was 2, 7, 2 would be there and 7 would actually be in one of those two. That would be fine. If this was 4, 5, I don't know, you can still fit 7 and 2 into those cells. Is it up here? Or is that, am I just... Ah, 3's in one of those two cells by ordinary Sudoku rules. Now, if it was there... This would either be 9, 6 or 8, 7. No, I'm just not getting anything. This can't be a 2? That's hardly relevant because of 27 in this row. Ah, 36 in this row, so it can't end with a 3. Good grief, how am I not spotting that? Right, and I was saying that if that was a 3. Ah, if this was a 3, yes, actually, we can't put a 9 in the rest of this box. So in fact, no, the simpler thing to do is to say you can't get a 9 into the 26 cage. So I think it's got to be 8, 7, 6, 5, 15, 20, yeah, 26. So there's no 3 in it, and that's a 7. In this row, 6 comes before 3. Here we go, we're off again. And 5, 6, and 8. That one can't be a 5. Now, we have dealt with this one. It was 9 7's 63. 9 6's a 54. So if that was a 5, this would have to be a 4. 1 3, so this has to be even. It can't be 1 9 or 3 7. So it's either 2 8 that way round or 6 4 the other. And we're looking for 4 before 5. Actually, that's been resolved in that column already. This is 2 before 7. This is 3 before 6. Okay, not getting very much further. This can't be 1, 3 or 5. Doesn't quite make it even, although nearly. Maybe this column again now. This is column 7, so 6 before... Oh, we've dealt with that already. 5 before 4, 3 before 6. Oh, 2 before 7 in this row. I've only just noticed that those mean that neither of these can be a 2. That can't be a 2 because of that. So in these 4 cells, 2 comes before 7. And 7 can't be there or there. So 7 is in one of these 2 cells. Goodness me, forced all the way into the 18 cage. And 2 is in one of these 3, which I am going to pencil mark, although I'll try not misunderstand my pencil marking. Now, if that was a 2, this is a 7. That would need to be a 9. That works fine, actually. 4, 5, 2, 9, 6, 8, 1, 3, and that would end up being a 7. So that works all right. If this was a 3, though, that would make this a 7, and this would be an 8. Yeah, that doesn't work. That's quite interesting. If this was a 3, this would be where 7 goes in the box. This would be an 8 to make up the cage. And if you have 7 and 8 here, you can't use 7, 2 up here, but you also can't use 4, 5, or you wouldn't be able to fill that cell. So that is not 3. That's 3. Now, you can't put 9 in this cage because it would be with a 7 and need a 2 here, which is impossible. So 9's up there. This cage is whatever 2 digits add up to 9 that aren't there. So that's a 9 to make up the sum. This is either 2, 7 or 4, 5, but it can't be 4, 5 because it's got a 7 in it. Therefore, it is 2, 7. This row has been done, importantly. This row is a 72 row, and we've got the 7 first, so that's been done. This is not a 2, 7. That's a 4, 5 pair. That's going to fix the rest of this cage. Also this 1, 2 pair. Sorry, I've just jumped into the wrong cell. There we go, fix that. This one is a right in 7. That has become a 4 now with 6 below it. Right, now we must be actually closing in suddenly. This can't be 3, 6 or 4, 5. If it's 7, 2, it's that way round. If it's 8, 1, it's that way round. Now in this column, 5 must come before 4. Aha! Very helpful. So that fixes box 8. That column is done. This is 3 before 6, and that's done. This is 2 before 7, and the 2 can't be in this top box. And it can't be there. So 2 is in one of those 2 cells. 7 is in... No, it can't be there because there's a 7. So that becomes a 7. Oh, that was much more helpful than I was realizing. Here we've got 1 before 8, but that's not very useful still. There's a 5 X-wing in those 2. So the 5 in row 3 is going to have to be here. Now, 1 before 8 in this row. That's not very helpful. 3 before 6 in this one. That means that can't be a 3. So 3 is in one of those 2 cells. 5 before 4 in this one. I saw that earlier and forgot to use it when it happened. Right, so that's done. So not many of those special rule rows and columns left to do. We've got 1, 2, 8, 7 to place in this row. They're not going in just like that. 3, we need a 9 in row 3. That's got to be here. And then the other two are a 3 and an 8. In fact, we know which way round they are, thanks to this. 1, 4, 7 up here. We know where the 7 goes. 1 and 4 there. Now in this column, 1 comes before 8, and that is looking a little more helpful. 1 is in one of those two cells. 8 is in one of those two. The 1s form an X-wing, which puts the 1 in column in row 6 there. That's a naked single 2. We can finish the row. That's resolved that 1 will come before 8 in column 2, so I can colour that. Now, 1 before 8 in this row. Only 2 places left for 1 are there and there. Okay, that's still not resolved. 3 before 6, I've sort of looked at that. Oh, the 4 thing there is going to sort out the 5-4 pair. Bottom 4 rows all done. This is a 1-5 pair. Yeah, they can be done. That fixes the 1-8 pair on the other side of the grid. In this row, I need an 8 and 3 and 4. Yes, I've got that 1-4 pair at the top. So that's done. 3 before 6 there. Still got the row 2 still to resolve, but never mind. 4, 1, 6, 2, 9, 3 here. So the 3 goes there, 9 and 2. Just the top 2 rows to finish. We now know that's a 1, that's an 8. I think I'm going to finish this off by Sudoku and then just check the last bit of the rule. 5, 4, yeah, that fixes 2, 5. We get a 7 here. And in this row, 2, 9, and 6, which must go 9, 2. And have we got the 1 before the 8? Of course we have, because Sajjad has created an excellent puzzle. Not really taxing, but really interesting with how the rule worked. And as I said, I loved the break-in with row and column 9 and 8 having to become before what and how this affected the 22 cage. Really clever stuff there. Thank you, Sajjad. As you said in your email, we did solve a puzzle by you some time ago on the channel, but really nice to have this other one. Very interesting idea, very well executed. Thank you as always for watching the channel. Hope the sound was all right this time and hope to see you again soon. Bye for now.